A square is inscribed in a quarter circle in such a way that two of its vertices are along the arc of the quarter circle. If the quarter circle has a radius equal to 1, what is the area of the square equal to?
So the problem states that we have a quarter circle and a square inscribed in it such that the corners touch the curvature of the circle. We know that the radius of the circle is 1, and we want to find the area of this square. By constructing these two radii of the circle, it can be observed that the two angles marked with orange will be equal because they represent the corners of an isosceles triangle. Consequently, the angles marked with blue will also be equal to each other. We denote the side of the square as L. By analysing the following two triangles, it can be observed that they have an equal angle between them, the angle marked with blue. At the same time, two sides are equal because they represent the side of the square and the radius of the circle respectively. This implies that the third side of the two triangles must also have an equal length. We can denote this side as x. Applying Pythagoras' theorem in the following right-angled triangle, we can deduce a relationship between the value of x and the square of the side length of the square, L squared. We construct the diagonal of the square. We know that the angle of the quarter circle is 90 degrees, which means that these two angles will be 45 degrees each. We also know that the diagonal divides the angle of the square into two equal angles, so this angle will also be 45 degrees. The conclusion is that the angle marked with blue is a right angle of 90 degrees. We also know that the square's diagonal d squared will be twice the value of the side squared. Returning to the right-angled triangle discovered earlier, having sides 1, d, and x, we can apply Pythagoras' theorem to deduce that the square of 1 equals the square of d plus the square of x. The value of d squared we already have expressed in terms of L, and from the first relationship, we can also express the value of x squared in terms of L. Replacing d squared and x squared in the relationship, we obtain the following formula, from where we can deduce that L squared equals 2 to 5, which represents the area of the square.
To solve this problem, consider the side of the square that's a chord of the quarter circle. Construct the perpendicular bisector of this chord. Since it's a perpendicular bisector of a chord, it will pass through the center of the quarter circle. Then, since we have a square, this will also be the perpendicular bisector of the opposite side of the square. Now consider this right triangle. By side angle side, we will have a congruent right triangle right next to it. Since these two triangles are congruent, they will bisect the 90 degrees of the quarter circle. In other words, these two angles will each be equal to 45 degrees. Then this means each of these triangles is an isosceles right triangle where each of the acute angles is equal to 45 degrees, and therefore the two legs of these right triangles are equal to each other. So this distance is also equal to the other leg of the right triangle. We will now use this information to solve the problem. Let's remove some of these markings. Suppose half the side of the square has a length equal to x. Then these distances will also be equal to x, and the side of the square will be equal to 2x. Now construct this radius of the circle. Since it's a radius of the circle, its length will be equal to 1. Now consider this right triangle. Let's just focus on its dimensions. Its shorter leg is equal to x, its longer leg is equal to x plus 2x, which is equal to 3x, and its hypotenuse is equal to 1. Since we have a right triangle, here we go again. We must have x squared plus 3x the quantity squared is equal to 1 squared. This means x squared plus 9x squared is equal to 1, which means 10x squared is equal to 1. Consequently, we will have that x squared is equal to 1 over 10. We want the area of the square, which will be equal to its side length squared. So it will be equal to 2x the quantity squared, which is equal to 4x squared. But since x squared is equal to 1 over 10, we can substitute in. Thus, the area of the square is equal to 4 over 10, or 0.4. And that's the answer.